Good morning, guys. Today our lesson is going to be about resistors and resistance. Okay? And you guys know anything about resistors or resistance right now? You know what a resistor is? They're computers, you say, Trent. Yes, they are. They're computers, yes. All different types of electronic equipment involves resistors. Okay, so today's lesson is going to, some objectives we're going to cover is, we're going to identify what resistors are. Secondly, I'm going to explain what resistance is. And third, we're going to correctly use the resistance color code chart. Now, I've passed a chart out to you guys. That is a resistance color code chart. It tells some specific information that I'm going to get into further here in just a second. But hang on to that chart. Then we're going to identify resistor color bands. Okay? And last, we're going to determine resistor tolerance. We're going to start off with, what are resistors? Resistors are important because they are control devices for electronics. Mr. Trent said something about computers having resistors. Yes, they do. They have a ton of them. Resistors can be a physical device that we can actually physically see. Resistors and resistance can also be physical characteristics of a circuit or component. Resistors allow a circuit to deliver the exact right amount of current, voltage, and or power to a circuit or device. Okay? So we can fine-tune an electronic piece with a resistor. That's the whole plan to the resistor. Now you say, what is resistance? Resistance is defined as the opposition to current flow. Resistance is a bad thing in electrical work. Okay? The primary purpose of a resistor is to control current. By control, we mean the limit, per se, or just also. A resistor is a linear device, unlike some other circuit components that are not linear, like diodes or transistors. Okay? Now, resistance is measured in what we call ohms. You guys have heard of ohms before? Yes, ohms and Ohm's law, that's right. How do you guys know how ohms is identified with a symbol? You know what that symbol is? Okay. The symbol is the Greek omega symbol you see right here at the bottom of the screen. Okay? Now that means ohms. And ohms is associated with resistance. Okay? Now, moving on, some symbols and characteristics. Resistors' schematic symbols are used to represent a variety of circuit components for resistors. You guys know about schematics, okay? We covered in our electrical principles class. And on those schematics, we have symbols that tell us how to wire a device and such. Now, in these schematics, we see these symbols. These are resistor symbols. Schematic symbol is a zigzag line. You see right here, A, B, and C. That's a prime example of a resistor symbol. A resistor looks like a tubular cylinder device. It's also, a resistor is often called a load on a circuit. Okay? Another important characteristic is the power rating. Power rating is related to the physical size of that resistor. Okay? They come in different sizes and shapes and so forth. Okay, now here is a prime example. Here is a resistor you see right here on the screen. 3 different sizes, okay? See these color bands on here? That's what we're going to focus on here in just a second. But there's different types of resistors. One type is what we call a fixed, okay? A fixed resistor is part of an electrical circuit and is used to reduce the flow of electricity. Now when we say fixed, it is a fixed resistance only. If it says it is a, for example, a 5 ohm resistor, that means that resistor is 5 ohms, no more, no less. Okay? Cannot be changed. The symbol for a fixed resistor on a schematic is right here. This is what you'll see. If we see this on a schematic, we would know this type of resistor that we need to install as a fixed resistor. Now let's jump on to a different type of resistor. This is called a variable resistor right here, guys. Variable resistor is able to manage the flow at specific levels. 3 types of those are a potentiometer, a rheostat, and a tap. Okay? Right here, this is a potentiometer. You guys know on your stereo systems in your car, you've got a volume button. What you have right there is a potentiometer. That's all it is. You've got this right here. If you pull that knob off that stereo, this is what you have behind it, right here. So as you turn that knob, you increase or decrease the resistance in that resistor. So you can limit or control the resistance with a variable resistor. Okay, here's a picture of the different types and such. Some that you see right here has little tuning pots on those. So instead of turning a knob, you can turn a small set screw to increase or decrease the resistance in that resistor. So you can make it say a 5 ohm, or you can turn it up like a 10, 15, whatever. The symbol for a variable resistor is right here on the bottom. This is what you can see. So if I see on a schematic this symbol, that would mean I would need to install a variable resistor. Okay? A resistor will drop or use some of the supply voltage as current passes through it, meaning it can decrease or increase as well. This creates a voltage drop across the resistor. Resistors will have a voltage drop across it and current flowing through it. The two things multiplied together are the electrical definition of power. Okay? Now, a resistor consumes power as it does its job of limiting current. Okay? A resistor is not designed to produce heat, but heat is produced when the power is consumed. This is called self-heating. A resistor needs to be able to dissipate the heat it generates, or it will burn up. Meaning that if it doesn't get rid of it, it will eventually burn itself up. Okay? It'd be no good. Now, let's move on. Resistors, we said, are classified by size. For example, the smaller, this is a 8 watt resistor you see right here at the very top. See how small it is? And we go all the way up to a 2 watt right here, much larger resistor. Okay? It's kind of a picture of what they look like here on the right side, the left side. Okay. Now, we get into something very important right here, guys. This is the color chart I passed out to each one of you guys. Each one of those bands that we see on this resistor means something. Okay? This resistor isn't etched saying a certain resistance that's on it. It's identified by bands. Each one of these bands means its size, tolerance, and so forth. So we're going to learn what those bands are. For instance, the resistor that you see right here on the top section of the slide here, this is what we call a 4-band resistor. Self-explanatory. It has 4 bands on it. Okay? Now, the bottom resistor is a 5-band. Okay? So on a 4-band resistor, the first band is the first digit of that resistor. For example, the first band is what color, Trent, right here on this resistor? Green. So I come down and green has a value of what? 5. So the first digit of that resistor size is a 5. Okay? The second band, this means, is what color?
Blue.
Blue. Blue, I come down to the second band. What is blue worth?
6.
6. So now I have a total of what? What's my total resistance right now? 5 and 6? 56. Okay, so 2 digits. First digit's 5, second digit's 6. Okay? The third digit of the third band is what I say is my multiplier. Okay? The third band is what color? Yellow. So I come down and yellow is 10K. K means what, guys?
1,000.
Huh?
1,000.
1,000, yes. K means 1,000, so 10,000. So I take 56, my first 2 digits, 5 and 6, times that by 2. Okay? Now, the last band is what color?
Gold.
Gold. Gold is my tolerance band. Okay? Gold is worth what, Trent? 5%. So that means 56,000 plus or minus 5% is the tolerance that resistor must be within. If it's not, that's a bad. That is a bad resistor. Okay? Alright, let's move on. Here's a memory device to help you remember that chart if you don't have that chart in front of you. Memory device is big boys race our young girls, but violet generally wins. B meaning black, boys meaning brown, See the scenario there? That's a memory device that can remember that. Okay, quickly. Okay, identifying the bands. I need to know which band to start with. There's a certain sequence I must follow right here on these resistors. The band closest to the end cap is my first digit, or my first band I start with. Okay. You see the gap here? See that? So I would know I would need to start. This is my first digit, not this one. Okay, on that particular resistor, because it's closest to the end cap. Okay, let's move on here. Here's an example, guys, right here. This resistor. Which one am I going to start with on this one? The left side, because it's closest to the end cap. Good, Trent. That's right. So that first digit, use your chart. That first band is what? Brown. And brown is worth 1. So my first digit is 1. My second band is what color? Black. What is black worth? 0. So I have 2 digits now, 1 and 0. So I have 10. My third band is red, which is my multiplier. So 10 times, what's red worth? 100. 10 times 100 is what? 1,000. That's right. Now, the last band is my tolerance, which is gold, and it's 5%. So I have 1,000 ohm resistor, plus or minus 5%. Okay? I calculate plus or minus 5% off that. 1,000 minus 5% is 950, which is the minimum tolerance. And I add 5% to it, and it's 1,050. So that resistor has to fall between, when I check it with a multimeter, it needs to be between 950 and 1,050 ohms. If it is not, what is wrong? It's bad. That's right. Resistors can be bad and physically look perfectly normal. We have to use multimeter to determine if they're good or bad. But this is the first step, determining the target size and its tolerance to determine if they're good or bad. Okay? And I just showed you how to figure tolerance. Okay, so any questions, guys, so far? Everybody good on the color chart? Okay, so what we're going to do, our activity for today.
So if the band on the resistor on the right hand side, so if it was closer than the one on the left hand side, you start on the right.
Exactly. Trent's question was, he said, if it's closer on the left hand side than the right, he would start with the left hand side. Yes, you'd simply flip that resistor around and start. Because if you lay one down on the desk, you don't know which end to start with. So I need to physically pick it up and look and see which band is closest to the end cap. And that's my first digit.
To the left.
Exactly. Okay. So today's assignment, guys, activity is you'll get groups of 4. Okay. Each group will be given a worksheet. This worksheet has 20 resistor colors on this worksheet. Okay. You will use the color chart to determine the target size, and then we will calculate the minimum and maximum tolerance this resistor must be within. Okay. And then once we get done with this, each of you guys will get up, we'll present our findings. Okay, so Trent's group will say, for resistor 1, they found it at this target. Ms. Meese's group, she'll get up and present and say, okay, we found this resistor at this target size, this minimum, this maximum value. Okay? Any questions? No questions? Good deal. Thank you all.